Okay, so if you can open it up. We'll kind of complete the first, we'll do it only using, and then think about, the think is still thinking there. We'll come back to it, okay? If name and initials are always also required. Okay, let's look at what we were doing. I'll refresh your memories. It's the best way to refresh memories is to draw your ERDs. And this was to do with players. Sports 1 or 2 should be. Okay, so here it was, right? Information about players in the players table, teams in the teams table, matches that were played in the matches table, if players were any committee members in the committee members table, and then penalties done by in the penalties table, right? That's what where we were. And in question wise, we were doing two. Oh, so we had already, okay, we were at 3. It says get the player number of the captains who have incurred at least one penalty using a subquery. I'm going to do joins and outer joins and everything first, and then I will add the name and the initials, okay? So the player number of the captains who have incurred at least one penalty. So the captains are coming from teams, and if they have done a penalty, that table is table penalties, and we have to join those tables such that the player number is equal to the captain. So the join is okay, right? Then we did a left outer join, and we said in left outer join, which team? Oh, here we said we can't say which one was, because teams could be more or penalties could be more, whatever it was. And we said the player number. So this was also working. And then we had come, and then here is where the think process had started. Because of course, okay, here, if name and initials are also required. So the first thing that we did was, or I said, oh, let's join the third table. And the third table was, so the player name was coming. The third table was table teams was one player, which was already there. And we added the table players to it, which is okay. So this is the one we were working on. And captain, and what did we want? We wanted the player, the captains were in the player number of the captains. Okay. Player numbers from the captain is coming here, and the player name and the initials are coming from the P table. Okay, that's also good. This should work. So now the conditions, the joining conditions. Player number of the table should be captain. That's the right one. Captain, I think we have an extra condition here, don't we? Captain of here should be the player number in the penalties table. Player number of the table players should be equal to penalties player number. This is no condition at all here. Let's think about it again. So 3 tables being joined. Let's go back. We want the name and the initial of the player. So that's the table. People who have made penalties and are players are these 2 tables. And these 2 tables are connected with the player number here. So teams with players and penalties with players. That's how it is. Yes, that's how it is. Okay, so let's go back. Yeah. Thank you. Okay. So this was where we were. I had written a think here, right? So we said, oh, we want the names and the initials also. So we added the name and the initials, added the third table players, added the conditions, and the conditions is what we were adding on, and where we kind of thought, oh, what should we do? Okay, so the player number of the penalties should be equal to the captain of the player numbers. That's the right one. player number of the player table should be equal to the penalties player number. That also looks okay. And there was a third and there, which I thought we didn't need. And let me think why. So if this player captain and this is matching, we've already matched it. All we want is to match this player. Yep, there. So the think process I had added a third condition, but that third condition is automatically coming from these two. See, if PP player number is captain and PP player number is player number, this condition that P player number is equal to captain automatically is included. So that third condition was unnecessary. So 3 tables, true joining conditions. So using an inner join, so this is how we had started. We wanted captains who had paid a penalty. So the captain information was coming from teams table and the penalties was coming from penalties. We show the player number and the job was done, right? I did an outer join and the job was done. Now we said we also want to show their name and initials. We also want to show their names and initials. So as soon as we show their names and initials, we had to join a third table. We joined the third table into it. And as soon as we joined the third table, we had to add a condition. There it is. Right? So that should work. Let's try it. I can't remember now, but I think there were 2 captains who had done it. Were there 2 or 3? I can't remember, or more. Oh, 2 captains. So there. The information is right. So it should be the same in all answers. This one also, but these ones were only showing player numbers. Now they're showing their names and initials. Okay. So, but now I've done it using joins. We still have to do it maybe outer join. So this is right. There's nothing wrong in it. This is a right answer. There was an extra condition which I was thinking we don't need it because we've already checked player number is equal to captain. So we didn't need that third condition I had because it was default. It was the indirect that was coming. Now, is that the only way to do it? No, because if we have a left join here, I must be able to do with a left join here also. So now think about it. We need to know captains who have made penalties, their number, name, and initials. So 3 tables are involved. Now, if I can do this, the person is a captain and has done a penalty. If I can find that out, which I already did with the outer join. And then all I do is I do an outer join with the players table to get the name and the initials. Why can't I do that? If I can get this information, you are a captain, you did a penalty, and what is your name and initials? Let's try that with an outer join. Okay, so since I've already, and you don't want, if you don't want the player number, just remove it. It says if name and initials are also required. So let's do it only using outer joins now on tables. Okay, so let's, do we get more than one? No, we are getting it only one. Okay, so let's do this. So let's select. I'm using outer join now. This is using inner join, which we were doing last week. There was an extra condition, and that's why I was thinking something is not right. Okay, so let's take the player number, the initials, and we also want the number. Let's see if I can get it. Why not? I'll try to write the most efficient one. So 1, he should be in the team. So he's a captain in the team and he's done a penalty, which we couldn't decide if it was more efficient or not. So the same thing that we did here. You just have to add to it. This is what we did when we did not want the player number and the initials. We've already, oops, wrong one copied. Sorry, left outer join one is what I wanted to copy. Okay, I've just copied the left outer join once, but now I also need to join player name and initials to it. The captain was already there. So if I have to do that, I have to add another table, which means I must do another join. And I'm trying to show you with only left outer joins because of the simple reason that it can be done. Okay, so teams have been joined hands with penalties on the captain number. Okay, we'll have to be just careful about this, okay? Okay, so select the player number, name and the initials, take the team's left, join it with penalties. And how do I join it? On the player number is equal to captain. Okay, that's also fine. Now, one more join to be done. Okay, so till here we've done it. It has already been done in outer join. Oh, and this stays. The where condition will come at the end. That's all you have to remember. And put it in between. So I've just copied the outer join here. I've added 2 fields here. But if I add 2 fields, I have to do another join. So do an left outer join with your third table, and your third table was called table players. You need a third table. That's all you need. And a join condition. And how will you join? Same way that you joined the previous one, actually. Okay, so the table players, these guys have done a penalty. So they are in the penalties table. They are in the teams table. And now to do it with the players, the player number here, oops. This is the condition, the joining condition. This player number should be equal to the captain of the team. There, hopefully. So join your third table, and what you are saying, the player number should be a captain. That's what you're saying. So first the teams have been joined with penalties, which we already did, and we said, oh, they do match. And then we are saying now join it to the players table and join it such that the player is a captain. Looks okay to me, but we can try. So going from one to the other, the third table had to be added. That's all. So I added the third table. As soon as you add the third table, you add a new condition. In the outer join also, I picked up the outer join from here. I picked it up. I added a third table and I added a joining condition. Should work. I think should work. Let's try it. Oh, okay. We just need a distinct there. It is working. We just need a distinct, because if a person has done more than one penalties, he will match more than one records. But it is, so you need the distinct here. Look at the result. The result is not wrong. Parmenter R and Collins D are the 2 persons who are captains and have done penalties. But because they are coming more than once, all you do is you add distinct here. And the job is done. There, we've done it. We've given the number, we've given the name, we've given the initials. But because the record was coming twice, that means this captain guy has done 2 penalties. So if you don't want to see twice, we just put a distinct in front of it. We weren't getting that problem in the first one because of the inner join. Yep. You can write it in different ways, but I think that's more than enough. If you know how to do the left outer join, you're more than enough. You could just change the tables. You can start with teams and players and penalties and so on, but I just used the same solution that we had done before and I added the third table to it. It just made more sense. So here they are, right? So that you can compare. So I had this already. Captains who have done penalties was this, which was very easy. Captains who have done penalties. And then all I did was I added my third table to it. And I have a distinct there, so definitely I need a distinct here, because there also we must have been seeing duplicate, right? So captains who have done penalties, so the captain is coming from the team, the penalty is from the penalty, join them on captain. I just took the same thing and I kind of repeated it here, but now I need their names also. So I did a left outer join on names to get the names and initials, but I had to put a joining condition and I said that player number should be a captain. Right? That was it. It should be he or she should be a captain. And I have to put distinct because we just noticed, do we need a distinct here? I don't know. Do we need a distinct? Yeah, we need distincts everywhere, because if a captain has done more than one penalties, he will occur more than once, which you can leave if nothing is said. If only names and, I mean, that depends on the question. And hopefully I'll be clear in my exams. If not, you can always ask me. When you're creating an exam, sometimes you forget things, like with assignments also. When I start marking it, though I've done them myself, that's how I match that your answers are correct. But when I see somebody else's answer, I say, oh, that's another way of doing it. Then that's how it strikes, right? So it's not that I am always right and I know all these solutions. Maybe you can come up with another solution, but this is what is coming to my head right now, and it works, and I know logically it is okay. But if you have another solution and logically it is right, I don't dock off marks just because it doesn't match my solution. So as I said, I just took what was there, I added the third table, and I added a joining condition to it, and it should work. And it does work. And distinct because we don't want to see it more than once. So both of these should give you right answers. And of course, we already know that 6 and 27. The only thing you have to check is, are their names what they are? So you can check, is 6 and 27, which I'm hoping is right. 6 and 27 is Parmenter R, and 27 is Collins D. Yeah. I mean, we are assuming the answers are right, but yes, the answers are right. And the 627 were captains. So this is where we left off last week, because the thinking process, I added the third table, but the joining condition was something that I was stuck at. It stops working around 2:45, right? Same with outer join, I added the third table and added a condition. So that takes care of, now let's write it in a subquery. So the person is a captain and the person has done a penalty. This is an easy one. So is he a captain and has he done a penalty? Is not so tough to do. So let's select the captain. And we will give him a name, player number. That's all that is asked for now. No names are asked. And this is coming from the table teams. And this person number should be in where? In the penalties table. Oops. Okay. So select player number from the penalties table. There. So he is a captain and he's done a penalty. So that's the subquery. So select the player number from penalties, and if this person is in there, again we'll have two of them, I think, because this captain has done 2 penalties, or not. Oh, because we are only doing 6 and 27. Oh, okay, that's fine. The duplication comes when you start combining it. He's a captain because he's coming from teams. There's no need of distinct because each team only has 1 captain. It's when you start joining it with the third table. Now, if names and initials are required and we need to use a subquery. Any way else you can do it? This one? No, this is the only one I think we can do it. Any other way we can write the subquery? Though it's silly, we can say pick up the player from here, and if he's a captain, I mean, I can write it, but that's kind of silly. That's less efficient. You can do this. You can select. I mean, I can go the opposite. I can say select the player number from the penalties table. If where this player number, I mean, I can just write it the opposite way. Select the captain from the team. Though the other one is better. Why? Because if the question was which captain has done a penalty. So it's better that you find who is a captain before saying who has done the penalty. So this is not as efficient. Where player number in, select captain from table teams. So this is definitely less efficient. I mean, even if you look at it, I mean, it should work, but it is less efficient. Oh, now it will come thrice because because we are now picking up from the penalties table. So this is less efficient. So it's basically saying who all did penalties and then are you a captain? Whereas our question was a captain did a penalty, right? So it would be better to go the other way. It's not wrong, but it is less efficient. So you can say less efficient, but I mean, as I said, sometimes mind just works some way. And I'm not docking marks for efficiency or non-efficiency in the assignment or in the exam, just because I know that it takes more time and more practice to find that out. But redundancy, definitely. Redundant means you're adding a table which is not required. That's redundant code, right? Or you're adding a condition that is not required. That's redundant code. So definitely there you will lose marks, but efficiency wise, you're almost okay. I've seen that most of you have done it okay. Of the 10 assignments I have marked, I'm working on it. Anyway, now if names and initials are required, and this has to be answered using still a subquery. Okay, so if name and initial and the number also, oops. As soon as you say name and initials and the number, we may have a problem. Because how will we get it? As soon as we can get the, okay, let's try it. I don't think we can do it. We can get the number also. Select the player name and the initials. This will come from your table players. How will I get the number? Oh, he has this table also has a number. Oh, definitely it has a number. Oh, I can get it. I can get it. Except that I think they had a number. Sure, they had a number. I can get it all from the see. Whenever you do a subquery, all these fields that you are writing here have to come from this table, because the others are in the subqueries, unless you use where exists and all that. No, even that, no. Wherever you do something like a subquery, all these fields have to come from this table. So, or you do something that we did before. We found out, we created a variable, we put a value there and so on. But this should work. Okay, so now, which players am I interested in? Only those players who are captains and have made a penalty. So you can again write it in two ways. First, let's find out, is he a captain? Where the player number is in. And let's select the captain from the table teams. So he's a captain, right? So we've reached here that he's a player and he's a captain. But this captain must have done a penalty. So we'll select captain from table teams where this captain is in. Select player number from the penalties table. And again, I can write it the opposite way, like I did in the less efficient one. Spelling is wrong, penalties. Okay, so get the number, the name, and the initials from the players table. I don't think we will need distinct because it will only occur once. This player is a captain, and this captain has done a penalty. It should work. Or I can do the same thing, but in a different way. I can say select it from players where player number in, though which is less efficient again, because there is a less efficient subquery where the table number is in. So you select the player number from the penalties table. So he's done a penalty. And this player number is a captain. And this player number is a captain. So same way, I wrote the subquery in two ways, in which we said it's better to find out he's a captain first before he did a penalty. So this is again less efficient, but anyway, player number from the penalties table where the player number is in, select, he's a captain. There. Again, less efficient, but should work. And we won't need distinct because we are picking it up from table players and each record is unique. So the only difference I've done is what I did in the previous two subqueries also. I selected the captain here first. Here I selected the player number from the two tables, and we said it was less efficient. And again, this will be less efficient because you're saying that you are a player in the penalties table and now you are a captain. Opposite would be better. Are you a captain and then did you do a penalty? For the simple reason you are looking for which captains did a penalty. So it's better that you first see are you a captain and then you see whether you have done a penalty. Though who knows? Captain from, can't say because of the tables. Let's try. So we should have the same answer of 6 and 27 and all subqueries being run. Okay, I'm running the subqueries now. So 6 and 27, 6 and 27, 627 R per mentor, 627 Collins T. Yep, they all work. Right? So whatever your thinking process is, it is a thinking process. There's no doubt about it. Joins and subqueries are a thinking process. It does take more time. And it's very odd, and I don't know, I can't remember who did it, but something is working, the answer is right, but the query doesn't seem to be right. Instead of saying, I've told you a correlated subquery which says exists in, the word exists is missing and they've used in and it is working. And logically, I don't know. But anyway, when it comes back to you, I have put a note for whoever did it and I can't remember. So the where exists has been replaced by in and it seems to work, which is really, really odd. Can we try it in here? And I'll show you what I mean. Here, see here. Just to, so when we say, I've said a correlated subquery is where you say where exists, right? And you kind of say, oh, it is in the join of such and such. And I've seen a solution where instead of saying where exists, something, whatever is in, and kind of whatever is in, what are we doing with plain number in here? Like this. So where exists has been replaced by this. So this is at line number 247. If you match mine, I'm going to do something. I'm going to try it and see if you can put your brains for me. So I'm going to take this. And these are people who have, but use exists operator. So people who have done penalties, right? People who have done penalties. And a student or a group has done this. So instead of using where exists, they've said where this player number, because they're picking up a player number, is in. And I took player number because this player number is penalties. And it gives the same answer. And it looked so odd because correlated subquery only uses where exists. So this player P is being used inside, right? Like here, it's being used inside. Therefore, I say where exists and I call it a correlated subquery. But if you kind of think of it, it's saying, oh, give me the initials of those players such that the player number is in here. And it worked. And I can't think logically, I know what it is doing, but syntactically, I can make sense of it. So let's try. So I'm going to try this. These are people who made penalties. And there were a few of them, right? So these are all people who made penalties. And using where exists is kind of makes sense. Okay, I joined the two tables and I said, do you exist and do you do here? Look at this one now. So 1, 2, 3, 4, 5. See, same answer. and I'm stuck. Like I'm seeing what is the database engine, how is it working? And if you kind of look at it, the where exists says that record must be here. And the second one says, yeah, that record must be here because the player number is in this table. It works. Because I've said select distinct player number here. If I had said a star here, of course, then it wouldn't have worked. But with this, I've replaced the where exists by in because I'm choosing a player number here. So this, I mean, in a sense, the where exists has been replaced by where in. And I'm still doing an inner and an outer subquery. I'm still saying your player number should be equal to your player number. And I saw this in one of the assignments. And this will only work because I'm the player number, I am not using a star here. If I was using a star here, definitely it wouldn't have worked. It wouldn't, and I can do this without a, I can put a star here and it will work. See, I can do this because we are not interested in, like, it doesn't matter. Where exists, it doesn't matter, and it will still work. Right? Doesn't matter because all you're saying is, are you in the join? But I can do a star here. This will start giving me syntax errors, I'm sure. Because now it doesn't make sense. Player number in doesn't make sense. There I get an error. So if you use star here, then exists is required because you're not, like you're saying where it exists. But this is something that is saying, oh, I'm only picking up player numbers here. So why can't I write it like this? Why can't I write it as a correlated subquery without using where exists? And this came up in somebody's assignment. And I looked at it and I thought, wait, like it's a correlated subquery without a where exists. And it's fun because I'm not using stars here. If there was a star, then I can use an in. I can use a star with where exists because all it is doing is saying do a join, and here is a set. Are you one of the records in that set? So that was something new, and of course, logically, I'm trying to put my head around it, but it is okay. It works, and it is logically also correct. The person is thinking, oh, I'm looking for player number in that list. Why can't I just write it like a correlated subquery without using where exists? But keep in mind, if it was a star, then it wouldn't work at all. Because you're using an in here and you're saying, oh, the player number is in this table. So you can't use a star here. It won't work with star, definitely. Whereas this will work with star. You can replace this by star and it will work. So again, God knows what that person was thinking, but whatever they were thinking, that was fine. But I want to bring this to your attention, and maybe if that group is here, because I don't remember who were the group members, please keep in mind that in works if what you're selecting inside the subquery is the same thing. Only then you're saying, are you in here? So I can say, is the student in this class? Because I'm talking to students, right? But if there was a mixture of things, mixture means star means so many other things, then I can say, oh, I'm looking for a student, but there is a mixture here, so I don't know. I can search. You can only look for a student in a student list. You can look for a car in a car list. So there is nothing wrong in replacing where exists by in a correlated subquery as long as it is logically correct. So because the inner subquery is only talking in terms of player number and we want it, that's what we want. I can do it this way. But I want to bring it to your attention that it is important that where you're searching has only the player number in it, not a star in it. Then it won't work. I showed you it gave me an error. Of course it won't work. It can't find a value in a group of different values. It can find a value in a group of the same values. So it came up in somebody's assignment and it took me 5 minutes to kind of get my head around, will it work or will it not work? Because I look at code and I'm saying it looks odd because it looks like a correlated subquery. As soon as I replace this by star, it will stop working. Right? But since that student didn't have a star, I can dock marks just because But just for your attention, keep in mind, okay? Keep in mind it can be done. So this is just an odd thing that I found in somebody's assignment. Odd because we haven't done it. With where exists, we just put a star here always. We just put a star here and we say, oh, that will work. And it does work. It does work. You can replace this because I must have copied it. I didn't bother to change it. But this will work with the star. Where exists works with the star because all it does is checks, are you in there? Is the record in there? So I'll say, can you star, just to bring your attention to you. But when you do something like this, you cannot use a star. It makes sense logically. It makes sense. How can you, where you're saying pair number in a bin of mix. Whereas in the first one, you're saying the record is in that set of records, which is okay. Right? So I can't. Anyway, that was something new for me because I've never tried doing it without where exists. I've never even thought that I should write a correlated subquery and look for an in. So I learned something from somebody's assignment, whoever it was. And because I learned something, I just brought it to your notice also. Okay, here, last question to do. Then we'll go to normalization. It says get the numbers, the player numbers, the name, and the initials of the players. This has just come because I changed the name of the table. Who are older than our Parmenter. So here the age is being used. Remember we had birth date or something. You can assume that combination of name and initials is unique. The solution should not display our Parmenter. So anybody who is older than our Parmenter is what I'm looking for. And it is saying you can assume that the combination of name and initials is unique. So we don't need distinct in a way, right? In a sense, it is saying, or if people have the same name and the same initials, that's also fine. Maybe we can show their birth date also with it, and then we don't have to go here. So let's look at the table first. So let's look at the table first. It says from here, everybody who is, so there was a birth date here. Here is the birth date, right? So that's the birth date of anybody. So our Parmenter has a birth date, and I want to find out all people who are older than our Parmenter. That's all I have to do. Then why am I bringing this to your attention? Because I'm going to use birth date here. And in birth date, let's look how we've done. I just want to say, can you do, it's a date. And if you have forgotten, I'm kind of refreshing your memories. A date has many things in it. You can extract the year out of it. You can extract the month out of it also, right? And you can use it as a normal date also. Okay. So because your final exam is next week and you have not worked with dates a lot for a few days, I'm just doing this extra example 1 and 2 I'm mentioning because date is powerful. I could be saying, oh, tell me everybody who was born in 1982 and the type is date. So to extract 1982, you will have to use the year function. Or if I say, tell me sales that were made in December, in the month of December, and the date, you'll have to extract the month out of it. Okay, so we haven't done dates for a while. And I thought I better kind of just refresh it. And I saw this question and it said, oh, good. Okay, so whoever is older than our Parmenter. So my first job is to find out what is the age of Mr. Parmenter here. So let's find his age first. And his birth date is given. So why even find the age? Why not use the birth date? Okay, so let's select the birth date from the table players. And I'm looking for Mr. Parmenter and I'm saying his name is Parmenter and his initials are R. And there is only one person with that name. Otherwise, we would have problems, right? That's why I've said the combination is unique. Okay, so select from where? His player name is, I think, Parmenter, and his initials are R. So I'm assuming this is a unique combination, okay? And again, it is not case sensitive, so I could have written a small r, but initials and are usually written in capital. Okay, so we have his birth date. So now what are we interested in? Older than him means they were born before him. right? So their birth date must be less than his. Okay, so what do we need? The number, name, and initials. Okay, so number, name, and initials from the table called players. Oops. And their birth date. Whoever is older, their birth date. And notice, I don't need any casting or anything here. You don't cast a field, you cast a value. If I was comparing, compare 20th December 1982, then before I use that 20th December 1982, I would cast it as a date. But here are two fields that are date types. Don't put a cast in front of it. I've seen it somewhere, maybe in the midterm. So you don't put a cast in front of a field which is already a date. You put cast in front of a value that looks like text and you want to convert it into a date. So anybody whose birth date is less than this guy was born before him, is older than him, right? So no casting required if you're using fields that are automatically. Yes, but if you wanted to say something like, oh, who were born before January of 25th, 1965, so that date, the text, you will have to cast it. So don't forget your dates, guys, okay? Casting text is not date and numbers are not dates. If you want to use them, you will have to cast them before you use them. But if you're using fields, then we are okay. So the numbers, names, and initials who are older than our per mentor are this. I can give you 2 labs to practice also. No, I won't give you till I decide what exam I want to make. If I give them, then I can't use those questions. Okay, I'll make the questions first and then I'll give you similar questions if I can make them. Join now. So people join. Oh, what do we need? What kind of join do we need here? Self join. Same table with the same table. I'm talking to the same table, so I need a self join here, right? Okay, and most of your joins were correct too. Self joins, you've done a good job with self joins also. Okay, so we'll take this again, except that I'll have to put a P1 in front of it or something. So I go P1, P2, and P3. Oh, sorry, P1, P1, and P1, sorry. And guys, if something is asked, if the fields, both names are asked, you'll have to write them twice. If two numbers are asked, you will have to ask them, you will have to just write them twice. P1 dot player number, P2 dot player number, P1 dot this, P2 dot this. If the fields are asked, you can't miss the fields just because you're doing a self join. Okay, so we need the number and the name and the initials of all those. And again, you can give them names if you like. Nobody stops you to make them neat. And some students just do it, and that's perfectly fine. Don't forget any of these small things because anything that you've done till date can be asked. Okay, here is a self join. And most of you have done it correctly, so I'm not so concerned about it. But I want to point out something which may not be true in this one necessarily. I think only a cup one has been wrong. Got my semicolon here, therefore I have a dead squiggly there. So the same table is being joined with the same table. And now the condition. The condition says where the birth date of the, now you can do whatever. You can do one condition where the birth date of the first person is less than the birth date of the second person. Now tell me something. If I have this condition, does this condition make sense? Think about it for a minute, okay? And this is what I mean by extra redundant code. If I've already said that one value is less than the other, automatically they're not equal. And I've seen this in a couple of assignments where you're saying, when I said in a self join that show me the pairs of all those customers who live in the same city. So you can't say the customer number 1 is less than customer number 2 and they are not equal. I mean, it's redundant. When it is less, it is automatically not equal. Right? So you have to be careful. So this is redundancy. It will work because it's just an extra condition, but it's extra work, it is less efficient, and it is redundant. You don't require it. If something is less than the other, automatically it is not equal to the other, right? So this is something I notice, and we don't need this. This is redundant code. Okay, and we still have to do, we haven't completed this. So the person who we are comparing it with is P2 dot's first what was his name, player name, is equal to Parmenter, and his initials are, is there any ambiguity in the player name? P2 dot player name, and we are okay, and P2 dot initials is equal to R. So this important assumption that there is only one R parameter has been done. There could be two, and then there will be confusion, right? You can't have two R parameters because then you have two birth dates, and whose birth date are you comparing? Therefore, in the question itself, it said that the combination of initial and the last name is unique. Because if we had two R parameters, then I don't know what will happen. We can try. I have no clue. It will either give an error, or it will just compare with the first one it encounters, and then will compare with the first one. Could be that. So if you have more than one R parameters in your table, I think it will just, as soon as it finds the first one, it will compare it with that and do. But you never know with, because I've already said the sequence of the columns and the sequence of the records is not determined in a table. But if you have more than one, it will just compare it with one, and God knows with the same one or with the two other ones. I can't say anything because that's how it behaves. So anybody who is older, I don't know who's older, but let's try. Unknown column birth date. Spelling is wrong somewhere. R is missing birth here. In P1 also. Second one. Where else? Are you okay? Okay, let's try it again. So we'll have to find out, still an error. Unknown column initials. Initial in where clause? 322. And initials, thank you. God, how many errors in one query? Okay, so we'll have to double check. I don't know if, oh my God, quite a bit of people are older. Seems like everybody is older. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people are older than Mr. Parmenter. Let's find out his birth date first. And maybe it is easy to say who are younger than that. And let's do that. That way we will know if the answers are correct, right? So let's see the people who are younger. I'll just do the opposite here. These people are younger. So we had, how many did we have? How many were returned? Oh, is our Parmenter also coming in the, no, he's not older than himself. So equality is not to be given, okay? 10 rows are coming. Let's see how many or the others are coming. Let's try this one. People who are younger. Then we can total up and we can know that our answers are right instead of double checking. 3. 10 and 3 is 13. How many records do we have in committee members? No, players. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and one more 14. Yep, 10 and 3 is 13, and Mr. Parmenter is 14. So 14 records, 10 and 3 are the right answers. Right, so this is another easy way of checking your answers. Always double check your answers, because you may have an answer, but the answer may be incorrect. And believe it or not, like 15A and B and 16A and B are supposed to have the same answers. They're the same question, but I found different answers for 15A and B, and the person or the group is not thinking, right? That's what it is. They're not thinking. How can A and B of the same question have different answers? That's ridiculous. That means you're not paying attention. So double check your answers, but in the same question, you're doing it two different ways and the answers are different, means definitely something is wrong. Right? So you have to be careful. So I won't give you, how many did you have? 16, 18. 18 questions you got in your assignment. You're not getting 18 in the final exam for sure. Definitely, because it's too much to do in 3 hours. So I'll give you, I'll kind of keep it to 10. Not more than 10, because joins and subqueries does take practice, right? So that was the main aim. And as I said, most of like the 10 that I've marked, most of them are good, like it's been thought about. But if you do mistakes like this, that really means you're not paying attention to your answers, which you should. Okay. Okay. So that completes it. So we are right. I'm assuming we are right because we kind of did this check for the 3 and 10 and 3 was 13 and one Mr. Parmenter was 14 and it was okay. Right. That takes care of joins and subqueries from my side. We did it for quite a few weeks. And this is your main emphasis in the final exam. 75 to 80% is this. The other things, when I say other things, using functions, count, sum, grouping by having, all those are extra things you did. But all questions will be joins or subqueries. Definitely, because I'm not going to ask you simple select statements now, right? So all will be joins and subqueries. On top of it, the small things that you've done, I say, may be used. You may be using count, you may be using functions on the year, you may be using sum, minimum, maximum, all, any, all these things that you've seen, that's the extra work. But all queries, all select statements will be either joins or subqueries. So that's for sure. You won't have any simple select statement. Oh, yeah. If it is a coding exam, you can use whatever you like from your own computer. Your assignments, everything, like it was in a midterm. But you won't be allowed to go and research on the web. So you will be allowed to use the SQL manual as last time, but no other internet access will be. Oh, yes. Anything that was your own work is perfectly fine. Yes.
What if we make our own drawings?
Sure, if you want to. Doesn't matter to me. It's fine. If you want to make your own paper notes, that's fine by me. If that helps you. See, coding is all about, it's not something that you can learn in a day or do it just out of the blue. You can code because you've been coding over the semester. So it really doesn't matter. So, and I don't want to do multiple choice kind of foolish things because it doesn't make sense to me, because a coder should be able to code, right? That's the whole purpose. So it takes a lot of time to mark, like it will take me almost 5-6 days to mark your assignments, group assignments, though there are only 30 of them. But it still is what a programmer should be able to do, think logically. Okay, now, because I've been talking about normalization from day one, and I've not been able to find a good example for you, and I'm sorry that I forgot to put it on Blackboard. What I've done for you is I have created very simple normalization, and my mistake, I just forgot. I just did it yesterday, so I didn't put it. So I'm going to zip this up for you and put it on. Oh, before I do that, I can do something else also. I can do it right here since we are in this question, on this script, I mean, which I can do in normalization. I would like to introduce you, because it's something that comes handy when you're doing large applications, to something called a view. You've done tables which have a physical existence in your database. So they exist, right? They're physically there. But there is a data structure. It's a structure because it saves data, but it's not a data structure. It's basically a definition, and it's called a view. What you can do view, and that's specifically useful with joins, because what you do is you're saying, okay, I want to pick up something from this table, something from this table, something from this table, and I want to give it a definition so that every time I want to work with that set, I don't have to write my subquery or my join again. I can use the view to give me the answer. So let me show you what a view is, how you create it, right? And I mean, I can pick it up from here just because we are doing it. Not the last one was not so very helpful. Maybe this one. And just show it to you. Just show it to you how to create a view. So let's take something where we've already done it, like this one, where I've done a join or where we have done a subquery. It can be applied to anything. Let's I mean, it can be applied to anything. So a little tough one here. How do you create a view? So I'm going to introduce you to views, and though you can do everything with a view, it is highly recommended that updates and deletes must be done on tables, physical tables, and not use views with it, because there's so many restrictions on it shouldn't have group by, it shouldn't have having, and so on. So though views can be used as if they are tables, like as if it was a table, it is highly recommended that you can do selections from a view, but you shouldn't be doing updates and deletes using a view, because there are so many restrictions and rules on it, right? But otherwise it's just what it is. So how do you create a view and what does it mean? It's just a definition. So I'm going to create a view, and of course it will have a name, right? So what is these? These are players who are captains and who have done penalties. Okay, so I'm going to give it a name that will make that I can remember. So I'm going to call it captain penalties. I'm giving it a name, like a table has a name, so does a view have a name. So why am I calling it captain penalties? Because this question is about captains who have made a penalty. So give it a name that you can remember. And then you can take this whole select statement. You can kind of put it just right here in opening and closing brackets. And say as. And what did I do? Copied something wrong somewhere. For sure I did. Okay, something is not where it should be. Oh, semicolon here. Okay, there. Now we are okay. So I just took the subquery or the whatever you had written, the join you had written, and I gave it a name, a new name. If you wanted, actually, just because I'm doing it, you could have created a new table out of it. I could have done create table, and I would have got a physical table that contains only this record. Have I shown you this before? I can't remember. You can create a table from this. This is absolutely logical. There's nothing wrong in it. So you write a join or whatever, and then you have a create table command, and you write something inside it, and it will create a new table for you. And this table will physically be present in your database. You'll say the users, now you have information at one place, and you can kind of just use it, right? So let me show this to you first. So I've created a physical table here, and to show that it exists, what will I do? Select star from this table. So the first table is only creating a table, and the way that we are doing is, oh, I just did a select of something and I have a new table now, right? It's just all you did was you joined some tables, you took out player names, initials, and captains from them, remove distinct for a minute so that I can show you something else on it, and then do it. Just run this, just this code. Oh, and let me show you that this table got created also. What was that command? Show tables, right? Is that all it was? Show tables? No, the describe is the structure. Show all the tables in the database. So I want to show you that this table got created. I think it was show tables. Let's run this. Hopefully, there. Notice how a new table got added, captain penalties. And this is the same result that you were seeing when you were doing your statement. So tables can be created like this too. You can create tables out of joins or subqueries. And sometimes you can create tables by union and intersections and all that also, right? So you can do that physically. But the disadvantage is that, oh, why would I do that if I already have this query? All I have to do is run it again. Right? So instead of that, instead of creating a table, so I'll kind of keep it here just so that you see it, just because maybe it's new for you. You can also create a view. So I'm going to pick up the same thing again. I'm going to say instead create a view. I'll repeat it here, but instead of saying create table, I'll say create view. And just so that we know that it is a view and it's not a table, that how we add TBL in front of it, I'll call view in front of it. I don't know what the short form of view is. I'll just say view. Maybe it's VW. I can't remember. And here I'll just say TBL because that's the conventions we have been following. Okay. Now let's see the difference between the two. And I'll again show the tables. So I've just said TBL in front of tables and I've said view in front of views. And I'll again show the tables to you. Okay, so you've already seen that in the previous one, this table got created because it was in the tables in my table. Now look at this one where I create a view. I'm running the same query again, nothing different, but the main difference is instead of saying create table, I'm saying create view. That's not good. That's not good at all. Why is it coming in the tables? Do tables also show views? No, it shouldn't show views because view is just a definition. That is strange. It should not show up the view. It is showing the view also. Unless I'm wrong. Unless I'm wrong in my interpretation of show tables. Maybe it does. And I could be wrong. Somewhere better. Reference manual. Why does it say 8.0? I kind of get so. Tables, show create function, show reference manual 13, show tables, show columns. What does show tables do? Does it also show the views? Non-temporary tables in a given database. Oh, non-temporary tables in a given data. You can also get this list using the DB name. Does it also show views? So optional extended modifier to no. No. It shouldn't show views. That is the main difference between a view and a table. Oh, this statement also, oh, there it is. Oops. Okay, it also lists any views in the table. Okay, so there is, I can prove it to you that it is not a physical table. Right? I thought I could show tables should only show tables, but it says it also shows views. Okay, so that won't do. So, but anyway, coming back to it, I can prove it to you that it doesn't have a physical existence because it's coming in the tables list. But the main difference is this. Now, this view that you've created, you can use it as a table, but it only has a definition inside it. It doesn't have any physical existence. It's only a definition that it has. So if I do it, it will work as if it was a normal table. Oops, now what? What did I do? Table view captain already exists. Oh, did I already run it once? Oh, good. Okay. Because I didn't drop it. Oh, God. Because I didn't drop it. So, drop view. You live and learn. If exists, view captain. So now I can run it more than one times, okay? We should have done that here also, which we didn't. We just created it, but anyway. And the semicolon is missing. Right? So it works as if it was a normal. Oh, do I have an error? No, I don't have it. No, I don't have an error, right? But how shall I prove to you that it is a definition and not an existing table? Now, if you want it, I mean, all I'm trying to show you is this also, which you could have done in tables also, but I can't. Now, if you want it, you can do this. You can say select unique or distinct, or you can say, you can kind of, you can use it as a table now. You can say select, what was it? What results do we have? Player number is same. Okay. So we can now say select star from this view captain penalties. There, like a normal table. You can use it like a normal table where pair number, that's, you see the three, the third one is called captain. Let's remove this just because it's how it is displaying and therefore I was confused. But anyway, doesn't really matter. Where captain, even if you leave it, is equal to 27. Is captain number an integer? Or captain numbers integer? We'll have to check. I think they were. Oh, another thing which is coming back, and it's very common, guys. It's really common. In that particular database, though they were called numbers, part numbers, what else was there? Rep numbers. They were all text fields. If you had looked at its definition, they were text fields. But 90% of the class has used them as numbers without quotes. So you will lose marks because in the requirement, it did say that text field should be in quotes and numeric field should be without quotes. I'm sorry, but I have to take them off. But 90% of the class has done it because they looked like numbers, right? Like everything looked like a number. Warehouse was a text field, but 3, 4, 10, they were all numbers. Rep numbers, 65, 25, 35, they were all numbers. They looked like numbers, but their data was text. So keep that in mind for your final exam at least. So it's not a big thing. It was only 2 marks. It was not a big thing, but I haven't seen a correct one yet. 90% of the class hasn't done it. So it's common. So people haven't paid attention. Anyway, so now I can use this table once the view is created. So once that view is created, even if you had a player number here, it really didn't matter. It really didn't matter. That was just a display name. But once you have created a view, so let's create this and just run this. Once you have created a view, you can use it as if you were using a table. Oops, now what? Unknown column captain. Wasn't it captain? Just because I've given it a name? No, doesn't make sense. Is the spelling correct, guys? Captain? Yeah, the spelling is right. Yeah. No, but here it was called captain, right? Here I said pick up the captain from the panel, from the teams table. Okay, so wait. Let's run this again. It has these, it should have these 3 fields or whatever number of fields. Okay, so 0 rows affected. That's okay. What is this giving me? 3 rows returned. Okay, it is giving me 3 rows. And now here, if I do this, what is it saying? Spelling of captain is wrong? No. Oh, okay. The spelling of the view is wrong. Okay. So the spelling, that's what I'm saying. It can, it's wrong everywhere. Oh God. Okay. So captain is wrong everywhere. So TAIN. Where else? TAI. Oh, it's wrong everywhere except. Are we okay now? Okay, so let's draw somewhere else. But that has nothing, I'm not even running that. That's a table. I'm not even going there. I'm only running this view. I'm only creating this view. View is created? Yes. Now, should I be able to select it from here? Yes. Yes. Now, if I can do that, I should be able to do this too. And yes, okay, so I don't know, somewhere something goes wrong. Okay, so you can use it as a normal table, but there is no way that I can prove to you that a view does not have, is not a table. It is just a definition. So it's not a table that has been created and put into the database. Whenever you do something on it, it looks up the definition of this view and then executes the query inside it and then gives you the result. So it's not a permanent, you'll say, what is the advantage? The advantage is that you have given it a definition, you have stored it, the definition at one place, and now you don't have to repeat this select clause over and over again if you were needing it at many places. That's what is the use of a view. So keep in mind that instead create a view which is only a definition. That is important, which I thought I could show it to you, but I cannot. I thought I would, which is only a definition and does not have a physical, it's not a physical table. It's just a definition. And you will have to take my word for it, guys, because I've worked in the industry for a few years with these views, right? So if we needed to run a join or a query or a complicated query over and over again, though it was only a copy and a paste, I mean, that's all it was. We created a view out of it, and then it was easy to say, select this from view, select this from view, instead of writing that statement. And I didn't realize that show tables also shows the views in a particular show tables. So I'll kind of Google it and see how I can prove it to you. But for now, you will just have to take my word for it, nothing else. I can't do anything else. Can you do what? So I was just mentioning it. You can insert and delete data from a view as if you were doing it from those related tables, but there are a lot of rules and regulations that you have to keep in mind. So when you create that view, it cannot have having clause. It cannot have something not null or null conditions. So all those things have to be kept in view, and therefore it is said that if you want to do updates and deletes, don't use a view. But if you follow that rules and conditions, yes, you can do updates and deletes with a view. And it will automatically do those updates and deletes in your related tables. Yeah, you can. Theoretically, you can, following rules and conditions. And there is a long list, so I don't want to go into that. But selections is no problem at all, because you're not touching anything. You're not changing anything. You can do updates, you can do deletes. You can do updates and deletes in views. There is no doubt about it. But there are certain rules and regulations of how the view is created. And if in the view you had a having clause, you couldn't have done it. If one of the conditions was, if one of the fields was null and you were trying to update it, you cannot do it. There are so many restrictions. But selections from views are, there is no problem at all, because selection just says select data. All right, so take my word that views do not have a physical existence in a database. It's just a definition. And the use of a definition is that once it is defined, you don't have to repeat that code. You can work with that as if it was a table. Okay. So we'll stop here with views. I just wanted to introduce you to views so that you knew what it was. So it didn't come as a, you didn't have a blank face if anybody ever talked about it. I'm sure you will learn more about it in your second course, but I'm not sure. I'll give you a break here. And by that time, I'll put on Blackboard the normalization file that I created but forgot to put. Okay. Oh, okay. So you are Joe. Okay. Yeah. So Joe, now who did this? Who has the final assignment? Do you have? Who's Nick? Is Nick in this class? Who's Nick? Is Nick in my class? Nick with the last name of, oh God, that's tough. With the last name starting with S. Okay, so no. So maybe he's in the other section. Okay, but you submitted the assignment, right? Yes. So you have the final copy of the assignment.
I have the final copy in my email.
in your email box.
Yeah, because I used two laptops. The original file is my other laptop.
Okay, now when was this email sent? August 5th. When was the assignment due? August 5th. Okay, so download this onto your desktop. That's okay, because the file you sent me is empty. Just put it on your desktop so that I have it. Now open that file. Just open it in text pad or whatever. It doesn't matter. I want to see it. Go down. Okay, so now what I have from here is an okay? So now submit in front of my eyes, submit this file on time. Yes. Did I tell you I didn't need a zip file in the announcements? But you sent me a zip file, and I have to unzip it and waste 2 minutes on it.
I'm so sorry.
That's okay.
If I would be, I don't get it.
I said don't send me zip files, and 2 people sent me zip files. That's why I said don't send me zip files, because I have to unzip it, extract a file out of it.
It's like send a zip file.
So 2 people, and I don't know about you guys, but the other group only had the SQL file inside the zip file. That's the one that's on desktop. Okay, so put it on blank.
And is my DRD okay?
I haven't checked it. DRDs are being checked like this. So that was only to say that you submitted. And I'll double check it, okay?
Yes.
Because I don't want to get into this again. So I was checking it yesterday, and I open your file, and the file is 0 bytes. So if nothing has been touched, then I'll of course take it. So let me.
I can see that.
Okay, so class scripts. Just give me 1 second. I want to put the normalization one on it, and then I'll. Because that's the only topic that's left. Where is Muhammad today? Is his back hurting, or is he just not attending class? Is he well? Where's Muhammad today, guys?
No, no.
You don't know. Okay, so.
No. Do you have your
I had the year.
Sorry,
I have it
something
now.
was-
That's okay.
Thank you.
You should always check, has it gone or not, right? That's your duty. Suppose now I was able to email you and I caught you. But if it's a final exam and you've left the country or whatever, and I can't find you, what do I do? Or if you had changed it after the due date, I wouldn't have accepted it, because who knows whether you did it before the due date or after the due date. So always be careful that you are giving the right file to me. I'll mark this, no worries.
Is it fine that we have did this one to many and this? Yeah, it's not the right.
No, you've given a legend here, right?
Yeah, that's okay.
But now I can't differentiate between.
Like this is a green.
Yeah, but this you say is the primary key. So where is the primary key of this table?
So it's like
Oh.
Like primary key and the foreign key for that. This is
Oh, okay. Okay.
good.
I don't know about anything else. That's the only question you asked me. I'm only answering that question about the green. Yeah.
I'm saying that is it fine that we have written like one to many, or else need to write the relation just like this?
Yeah, write one to many like you did here. Write it here also.
Okay.
Okay, because infinity doesn't make sense to me. And actually, you should write where the many is, you should write many on that side and one on the side where the one is.
Okay.
Right? Because that's the relationship.
Yeah.
Not, I mean, I don't know what is right or wrong, but many has to go where the infinity is and one has to go where the one is. Noel, who was your partner in the group assignment? Is he in this section? Okay.
Excuse me. So this is the hackathon.
Okay. Everything done?
Yep.
Okay. It's not complete, but that's okay. Because I don't know anything about relationships. What do two lines mean?
Oh, wait. Okay.
No idea. I have no idea.
Sorry.
Right? It doesn't mean anything at all. Okay, I can't tell you whether it's right or wrong, right?
Yeah, it's okay. Thank
Yeah,
you.
you're welcome.
What is later after the class? The
Normalization.
normalization.
Yeah.
Thank you.
Okay, guys, let's get this going and finish normalization. An important topic of designing a database, which I've been kind of mentioning, but what I've done is I've created 3 examples for you so that it's clear. Okay. Okay, guys. So please pick up the normalization example from weekly learning on Blackboard. It's under, oops, it should be under weekly learning. Am I in the wrong course? Yes, I'm in the wrong course. And it's called normalization.zip. I'm sure I put it under weekly learning, under class scripts weekly learning. Yeah, there it is. I've been talking about this design issue, that how important it is to design good tables right from day one. And somehow I've not been able to get a good example on doing it. So what I've done today is I've created, if you unzip this file, you will notice that I've created 6 files in it. They're all SQL files. So we start with not in normal form and then change it into first normal form. It is not in the second normal form and then change it into second normal form. It is not in third normal form and change it into third normal form, right? So now since you've done joins and all this, you know about more than one tables, this should make more sense. So what I'll do is I'll open them up in my editor here. And this one I'll save on your Blackboard when I'm done with it, but I'll save it on Blackboard. Forgot to do that. Just unzip it and then then open all of them. We'll do all of them, but I'll just kind of do them in sequence. Okay, so once you have all of them open, let me close this one. Let me close this one. Okay, so let's open up all the files from your normalization. Okay, so let me see if I can open all of them together. Doesn't seem like, okay. First normal form. That's strange that I should not be able to book. Second. Okay, so you should have 6 files, right? So they're called toys not 1NF, then toys 1NF, then toys not 2NF, and then toys 2NF, and then books not 3NF, and then 3NF. Okay, that's how it is working. Oops. Okay, let's look at what we've already defined them, but this one gives you a better definition or whatever. Okay, so let's start. Shouldn't take long. I should be able to yeah, I won't take more than an hour for sure. Okay, we've talked about first normal form many a times in class, and we have actually all our tables that we've created have always been in the first normal form, and I've defined it many times. What I've done here is I've taken a database, a very simple one, which is about toys. Oh God, I must have messed it up. Anyway, the DB, I must have made the change, and this one has become table toys. The DB name has kind of gone Yankee. So just change the database name, please. It has become DB table toys. So on lines 14, 15, and 16, just double check the name that it's done. So what I've done is I've created a database, and in there I've created a table, and that table is called table toys, and the table toys has a toy ID and a toy. So it's basically about saying, oh, this toy is available. This is a toy ID, which is of course increment, not auto increment, because toys don't have ID. And then there is the toy, right? The show create command is just to show it. You can remove it. It's not even required. Maybe I was trying to show something and whatever. You can remove it. The second table is about colors. It has a color ID again because colors don't have identification any other way. And I've said, you know what? I've opened the wrong one, haven't I? I should start with the not NF first. Let's try with the not NF first so that you know why I've done what I've done. Okay. Here, my name is wrong in the first line itself. That tells you I've been sleeping when I was doing this yesterday. Anyway, here it is. When is a table said to be in the first normal form? A table is said to be in the first NF, or you can write the full thing first NF normal form. If it has a primary key, which all our tables have had till maybe after week 2, and there is no repeating group of information in any column, right? So there is no repeating group. Now what I've done is, again, so please see that you change these names. This is me changing them to DB and then making a mess out of it. Not that it matters, but it's just not neat. Right? Now let's look at this table and you tell me why this table is not in the first normal form. It has a toy ID, which is the normal ID, auto increment, because toys don't have IDs. Then there is a toy, and then there are the colors in which it is available. And here is the data. So wiffle ball with toy ID 5. Don't ask me, I only know about frisbee, kite, and yo-yo. I don't know what wiffle ball is. Wiffle ball has toy ID 5 and is available in colors white, yellow, and blue. Frisbee is available in green and yellow. Kite is available in 3 colors, and 12 is available in white and yellow. Definitely it has a primary key. I made toy ID as my primary key. But notice the color field has a repeating group of data or information, right? Why? Because this is repeating. And as I said, repeating doesn't mean the same value. Repeating means the same type of information. And the type of information is what? The color, right? Color is white, color is red, color is blue, or whatever. This is repeating information. So this, though it will run this script. Of course, it should run unless I've made some syntax errors. And there you see, and it's something which is okay, looks fine. It says, oh, there's nothing wrong in it. But the problem of first normal form is this. Now, some have 3 colors, some have 2, some may only have 1. It's a very small table. But how do I know what should be the size of my field? How do I decide? Do I need 100 characters? Do I need 50? Do I need 40? And so on. And suppose I want to find out, is wiffle ball available in color white? What will I have to do? I'll have to pick up the whole colors field. Then I'll have to split it on the comma because it has more than 1 values. Use a string function to split a varchar field. Then check if it has a white field. So more work, right? So because a field has duplicate kind of data, it is more work to access each value. Quite logical. There's nothing wrong in it. And 2, I don't know what size I should assign. I could do a solution. I could maybe make 3 fields, color 1, color 2, color 3. But I'm still back to the same thing. How many do I make? 5 colors, 6 colors, 7, 2, 3, I don't know. And again, if you're saying it is available in white, I have to check all the color fields to see whether it is available in white. So definitely the first normal form, not being in the first normal form is not a good idea at all. So now what I'm going to do is I'm going to take this and I'll convert this one single table into the first normal form. And the rule is simple. Whenever you take a table which is not in the first normal form and you have to change it into the first normal form, you'll always have more than 1 table resulting out of it because I have to break up data, right? So to do that, now go to what is called toys first normal form. And again, the DB table toys had because I did a control find, but notice what I've done. Now this is very important because this may arise many a times in maybe while you are creating databases so that you understand. Okay, now what have I done? See what have I done? I've created a table that has information only about toys. A toy with a toy ID. First normal form, no repeating group. Perfectly fine. So the company produces all these toys. Now, if they start producing a new toy, all they have to do is add it to this table. In the previous one, suppose they start producing a toy, but they haven't yet decided on the colors, then half information is there and half isn't there. But this table is independent. Every new toy can be easily added to this table. Colors has a color ID and has color, which means red has 1, blue has 2, green has 3. Every color gets an ID. I want to add a new color to my color table. No big deal at all. I just add it. So the company says, oh, we weren't making any orange frisbees. Now we want to add orange as our color in our company. All they do is add it to this table. But now the third most important table is this. Where do I get the information which toy is available in which color? That was the information that was coming from your first table, if you notice. That's the information that was coming from here when you ran it. So here you could say, oh, toy 5, toy ID 5, wiffle ball has ID 5 and is available in white, yellow, and blue. Information was very clean. It was very clear, but it was not a good design. So now this information, I have to still preserve this information. And how will I preserve it? This is how I'll preserve it. In this third table, I'll keep a toy ID. I'll keep a color ID. And what will I do is I'll say, oh, this toy ID is available in this color. So what have I said? This toy ID is referring to a toy in the toy table. So there is a foreign key, right? This color ID is referring to a color in the colors table. So it has a reference key, a foreign key. And the primary key of this table is color ID, toy ID together. Because that combination is unique. 5 is available in yellow, so 5 and 1. 5 is also available in green, so 5 and 2. So you can make 5 as the primary key. The toy ID cannot become the primary key. The color ID itself cannot become the primary key because a color can be present for many toys. But the combination can become a primary key. So now you have 3 tables, a color ID, a toy ID, and a third table, which I have called whatever, table toys and colors. And these are how they look. So just the ID and the toy go into one table. Just the colors, I didn't give them an ID because color IDs are kind of not very useful. 1, 2, 3, 4. From the other table, I had 5, 6, 9, 13. So I copied them. And the third table doesn't look too nice. But what is it saying? 5 is the wiffle ball, is available in 1, white. 5 is available in yellow. And 5 is available in blue. You will say, but that's not a good table. How will I do this? But definitely now you've learned your joins. Now you can join any 2 tables to tell me which color is available, which toy is available in which color. Now you know your joins, right? So now if I say, can you tell me which colors is the frisbee available in? Okay, so let's try to find out. I want to find out what colors is this available in? Wiffle ball, which is basically 5. So what will you do? You will pick up, I know the name of we'll go with kite. Kite is small. We'll go with kite. We'll find 9 here, right? We'll go and look for this table for 9 and 9. Find out their colors from here and go and look for this table. So let's try to do that. Let's try to make that table that we just saw. So it's not that, oh, no, because the other table was so simple to read, I'll leave it that. You cannot do it. Design principles says the table should be minimum in the first normal form. So I have 3 tables. From 1 table, I went to 3 tables, but all of them are now in first normal form. So now if you wanted to see which toy is available in which color, what will you do? I want to see the toy name and I want to see the color name, right? So what will I do? You know your selects now. Do a select. Okay, so the toy name is coming from the toy, right? It was called toy. The color name is coming from the color table. It was called color. And the IDs are coming here. Okay, so I want to select the toy and I want to select the color. From which tables? From the toy is coming from the toy table. Hopefully that's what it is called. If not, we'll have to go and, oh, there it is. The names are right there. From table toys. And where is the color coming from? Right? And now, how do I join? How do I join these tables? But I also need my third table. Why? Because which is coming in which color is where? In the third table. So you will have to pick a third table also. I told you, you may need tables, though you may not need fields from it. And what are your joining conditions? You can put the word inner join if you like, for sure. Okay, now join. What is common? And the common is that the toys table ID. So you can, let's give it names. Table toys I'll call T. Table colors I'll call C. And table toys and colors I'll call TC. Okay, so what is your joining condition? They're not so difficult. T's dot toy ID. There was a toy ID there. Is equal to TC color. TC dot toy ID. I gave them the same name. Inner join would have been better than I would have used using. Anyway. And what is my second condition? And my second condition is my color dot color ID is same as my TC dot color ID. And you will have the same table that you just saw, which was not in the third normal form, but now it is. I'll double check if my fields are right. The names of the fields. Toy ID, color ID, toy ID, color ID. Okay, we are fine. Now, if I do this, I'll get that resulting table that you had. Which toy is available in which color? So it's not that I have lost any information. I have not lost any information, but I have to write a statement. I have to write a select clause to get that information. But if the design is poor, your table is doomed to go wrong somewhere in the near future. And think about it. If I want to add two more colors, a toy is available in 10 colors, how big a field do I make? Another toy is only available in 2 colors. Now, this is so independent. Toys can be added in the toys, colors can be added in colors, the combination can be added in the toy ID. And this is not so big. If that's all you want, create it a view, keep it, and run the view every time. So let's see, do we get our answer? So select and run. Or maybe we should run the whole thing, because it seems like I did changes and didn't run it. Uh-oh. Cannot add, or did I make a mistake somewhere? No, I removed it. 12,2. Oh, 12,2 is 13. I cannot do 13. Is 12 available? Oh, sorry, 13. Yo-yo was 12. What was yo-yo? Not yo-yo was 12. Yeah, that's the mistake I made. Sorry. Here, when I copied it, I made it 13. It was 12. Here. That was the problem. It was saying you don't have a 12 when you are adding 12. And quite logically, you know about foreign keys now. You can't add 12 if 12 is not available. Okay, let's run it again. There we are. No information is lost. You can show the toy ID also if you want. I mean, if you wanted to, it was no big deal. I can say show toy ID. Color ID is not very useful to show because they are 1, 2, 3, 4. But if you wanted to show the toy ID, you can show the toy ID. I have all the information that you had in the previous table. So wiffle ball is, of course, if you wanted to order it, it is automatically coming ordered because of how I've put my records in my tables. But no information is lost. And all 3 tables are in the first normal form. Right? So that's first normal form. So you'll say, oh my God, that's work. It was not in the first normal form. To convert it into the first normal form, I had to change it. But the question here is, why did you start with the first normal form? Right? When you create tables, you don't say, I'll create it however, and then I'll change it afterwards. That's not how you start. If you know your design principles right from day one, you will not design them badly. Right? This looks more work because we went from 1 table to 3 tables. But that will always be the case. If you do not use design principles correctly, you will always have to end up to restructure your tables, which means more work. And nothing is good for poor design tables. Insertion is not good, selection is not good, deletion is not good, because information is present at more than one places, or there is data integrity is lost. Something will be, there will always be a problem somewhere or the other. So this is first normal form. Got it? Everybody has it? Now let's go to the second normal form. Let's look at the example which says not in the second normal form first. So what I've picked up now is this table, whether this table that I have is in the second normal form or not. It's not the same as the first. Okay, let's look at the tables. It's very similar. I have a toy ID. I put some toys into it. I have toys other, which for a minute we'll look at it in a minute, and then we'll look at the definition. When is a table said to be in the second normal form? From last week, remember last week was the first time when you saw a composite key. I told you that if a table has a primary key which is single, then it is automatically in the second normal form. And then you don't even have to talk about second normal form. It's automatically there. The problem, not the problem, the issue to be taken care of comes when you have a table with a composite key. So let's look at this table that I've created. Look at the second table, which I've called table toys other for just for the heck of it. I couldn't find a better name. It has a toy ID, and it is telling me that this toy ID is coming from the other table, which is okay. That's perfectly fine. But it is telling me where is this toy available? In which store is it available? What is the inventory? Is it available 5 in number, 7 in number, so on? And it also has a store address. And the key of this table is the combination of toy ID and store ID together, because a toy may be available at Toys R Us also. The same toy may be available at Walmart also. The same toy may be available at Canadian Tire also, right? So only the toy ID will not work, because kites are available at many shops. So are frisbees, so are yo-yos, and so are wiffle balls, right? It's just a toy. You're talking about toy. So you cannot make only the toy ID the primary key. So you'll have to think of which will become a primary key. Can you only make store ID a primary key? No, because a particular store may have more than one toys. Yo-yo is also available. Look at the data. If you look at the data, you will see that I cannot make what I can. Can only toy ID be a primary key? No. I see repetitions. Can only store ID be a primary key? No. I see because store 1 means Toys R Us, and Toys R Us has wiffle ball. Toys R Us also has yo-yo. So I can do that. But look at the combination. The combination can be a primary key. Nowhere will you see a duplicate, because yo-yo is available at Toys R Us, yo-yo is available at Walmart, and there is a difference between that combination. Do you see? So the primary key of this table is the combination. Toy ID, comma, store ID. Now, what is wrong in this table that you can see by just looking at it? Look at the fields. Toy ID is okay, doesn't look too bad. Store ID is the store ID, that's fine. Inventory is telling me how many do they have in stock. What about store address? What is store address related to? Think about it. What is store address related to? What does it depend upon? Which field does store address depend upon? Come on, come out with it. You can be wrong. If you can be wrong, that's okay. Does it have any relationship with the toy? The address of the store? Does it have any relation with the store ID? Yes. Does it have any relation with inventory? No. So now in the second normal form, the definition says it should be in the first normal form, which it is. There is no problem in the first normal form. I see a primary key. I don't see any repeating loops. But look at this. Every non-key field. And what are the non-key fields? Inventory and store address are the non-key fields. Are completely dependent on the whole primary key. It's not dependent upon a partial key. So store address is not dependent upon the complete key. It is only dependent upon part of the key. This table is not in the second normal form. You'll say, what's the big deal? Why? What's wrong with it? Okay, let's see what's wrong with it. Suppose a new store comes up in Berry, right? A new store is created. That store ID and store address are okay, but yet they haven't opened up to the public. They're still stocking up or whatever. So they have a name and they have a store address. And I just want to keep this information. Oh, a new Toys R Us has opened, or a new toy shop has opened in Berry. So they have an address and they have a store ID. No big deal. But they are not selling toys yet. So where will I put that information if I wanted to? I couldn't do that. So I cannot insert new information without, I have to wait till that store starts selling toys, and only then can I do it. More than that, let's look at something else. Suppose Shoppers Drug Mart, no, it's not a good example. Suppose Toys R Us has moved from Bayfield and has now gone to, I don't know, Wellington Street, right? that information is present at as many places as the number of toys it is selling. So that information, that Toys R Us is now not at Wellington, but is not at Bayfield, but at Wellington is, look at this, 23 Maple here, 23 Maple here, 1902 Amber Line here, 1902 Amber Line here. Suppose now the address has changed. You will have to change this address in as many number of places as the number of toys it is selling. How foolish is that? Why would you do that? One, because it doesn't make sense. That information that this store has this address should only be at one place. And two, suppose I am updating my records and I have updated the first 3 records, I still have to update the rest of the records, and somebody comes and retrieves that record. I have incorrect data. So you've lost your data integrity. And that's very important. That's very important. So when you're updating your records and the updating is not yet, you could lock your table, that's fine. But what if you can't lock your table? What if the table is so important that it has to be open to the public 24/7? If you lock your table, then it's okay. Okay, I'm updating 23 Maple to 26 Maple at all places. That's okay. But if you cannot lock your table, and I've changed it in the first instance, in this first record, but the update has not yet occurred here, and somebody picks up this record, they have a wrong address. So update will cause a problem. Similarly with delete. Suppose I want to delete that, I want to say that toy, suppose I want to say that this particular toy, let's only look for something with the only one value, East here. Let's take this one. Suppose whoever this store is, I don't know who that store is, whoever this store is, who is situated at 100 East North Street, is now no longer selling the toy in color 3, 5 and 3. And that's the only record that was giving me that address, 100 E North Street. I've lost that information forever. I've lost the address of a store which may be required again. Maybe the store starts selling another toy after a month. I've lost that information. So deletion is also a problem because information is not present at the correct place. Because information is not present at the correct place, I cannot do updates correctly. There could be loss of integrity. I cannot delete a record if it is the only record that is available. And in insertion, I cannot add a new address of a store if it yet does not sell the toys in the list. So all 3 operations have problems. So definitely it is not a good design. So let's look at the definition again. It says a table is in the second normal form if it is in the first normal form and every non-key field, that is a field that is not a part of the PK, is completely dependent on the whole primary key. It is not partial. There is no partial dependency. Not on part of the key, on the whole part key, not on any part of it. And therefore I say if a primary key only has a field, where comes the question of whole dependence or partial dependence? Partially, you can only depend on something partially if it is of more than one parts, right? So what do I do? So here we see that store address is dependent on part of the primary key since it only depends upon store ID. That means this table is not in the second normal form. And because it is not in the second normal form, I've already talked about problems that will occur in updates, deletes, and inserts. So what do? I have to break the table again. So the first table is okay. The second table has to be broken up. Think about it before you see the solution. How can you break up this table? What should you do? What should you do to break up this table? You will have to break it up into more than one tables. What should be the 2 tables and what should be the fields in the 2 tables? Okay, so what is causing problem? The problem is in the store address, right? Let's keep the store address and the store ID in one table. And let's keep the toy ID, the store ID, and the inventory in another table. Problem solved. Right? New store gets added, I can put it in the store table. A store address needs to be changed, change at only one place. A store doesn't sell any toys, that's okay. It will go away from the first table, but we are not losing its address from the second table. Right? So that's what you do now. So you look at the table and you say, oh, The store address is that field that is only partially dependent upon the primary key. So let me put it in another table. So put it in a second table and move the store ID also in the second table. But the store ID is still needed in the first table because toy ID, store ID together is the key of that table. Because inventory depends upon what? Inventory says yo-yo is available in Walmart in 5 quantity. You can't do without it. You can't say, oh, 5 quantity. 5 quantity where? Of which toy? In which store? Right? So you will pick up this table and you will break it up into 2 tables. And when we break it up into 2 tables, we will get, so we'll run this. It should run, hopefully. Oh, no. Did I drop the table before I? Oh, table toy spelling is wrong. See? That definitely tells you that I was working late midnight. Let's run it again. I'll put this, no, still not. Error dropping, oh God, okay, now this is nothing to do with this could be nothing to do with this is, again, dropping database is causing problems in mine. So what should I say? I'll just make that no, not to no, okay? The dropping database could not be your problem at all. Still a problem, cannot add foreign key, where? Oh God. Underscore missing. I'm so sorry, guys. I really am sorry. This is really careless work. After telling you that you should not be careless. Okay, at last. There. So they were all syntax errors, but because I was half asleep when I was doing it, specifically it shows. But here are the tables. So here is information about toys, and here is information about the toy ID, the store ID, and the inventory and the address. So now it runs, it is okay. Now I know it is okay. But we already concluded that it is not a good design. For all 3 reasons, for insertions, for deletions, and for updations. So what do? I change it into second normal form. I'm just going to check if all my tables are running. Okay, this one runs. This one runs. Okay, now let's see what will I do. I'm going to change it into a table which is in all the normal forms. So a table is, I've only repeated the definition for you. A field or part of the is completely dependent on the primary key. I've already repeated it, right? Now let's look at what I did. Did I touch the table toys? Please do this change here, right here, guys, before I kind of go ahead. The underscore, just do it. Oh no, don't. We'll have to do it at many places, guys. Leave it alone. Let's do it with with Control F. So edit and replace. If you don't want to do it, don't worry about it. Where is my replace? Edit and find and replace. Okay, so I'm going to find table toys everywhere. I don't know how I did this. This is really silly. I must have taken some old script and tried to make changes to it, and therefore there's so much mess in it. And I'm going to call it table, if I can see it properly, underscore toys. Okay, replace all. There, okay. So now this table, it still says drop, not in second normal form. We'll put it in normal form. I'll create a new database with in normal form. The not was anyway giving me problems. Okay. So what have I done? Let's look at it. I've not touched the first table at all. It's the same table. I haven't touched it. I've just put the values 5, 6, 9, 12. Though it is an auto increment key, you know that. I've told you if it's an auto increment, it's better not to touch it. But I'm kind of going with the same example of 5, 6, 9, and 12 using the same data. So I put in the value myself, which you can do. Nothing stops you. You can make it unsigned. It would be better to make it unsigned. You can make it small int also. Oh, shouldn't do it because then I'll have to make changes everywhere. Leave it alone. Well, anyway, right? Now let's look at the second table I created. I created a second table called table store information, in which I've kept a store ID and I've kept a store address. Of course, you could have created an auto increment key for store ID. I just chose not to. I just chose not to because in my previous table, I think my store IDs were all very different. Okay, I just chose not to. You could. And my third table, you can. There's nothing that stops you. I have given them 1, 2, 3, 4. And notice, one store address has a ID and a address, a ID and a address. And what is its primary key? The store ID, its primary key. And now look at the third table, which will not make any more sense than what it was, but I have it. A toy ID, which is coming from the toy table, a store ID, which is coming from the store table, and an inventory, which is basically, it's saying an int, how many? Again, it should have been unsigned to start with. My fields are not very good at all. I'll make all these changes and I'll put it finally on Blackboard for you. Though, again, here the emphasis is more on design issues, but I should still use the right kind of fields. And I've put values into it, right? And then I do selections. Now, these values kind of look odd. They don't tell me which store has which toy. But again, what can you do? You know your joins. So if I want to find out, is wiffle ball, what is the inventory of yo-yo in Walmart? All I have to do is pick it up from the three tables. So the name should be Walmart, the toy name should be yo-yo, and then pick it up from this table, join the three tables and get your result. Now all these three tables are in second normal form. Why? Because this has a primary key which is composite, but it only has one more key field which is inventory, and it depends upon the combination. And the store and the store ID and the store address have gone in a different table. No problem at all. Insertion, I can insert information about a new toy, a new store. Deletion, if I want to delete a store, they've left Berry or they have stopped selling toys, I just remove it from my store table. I don't have to worry at all, right? A new store has come up, will eventually sell toys, but yeah, it is thinking, I can put it in the store table. New toy in the toy table. New toy in another store in the third table. Delete something only at one place. Update something only at one place. So see, I'm not losing any information anywhere. So a store may not be selling any toys they were selling. They are not selling right now for whatever reason. They will sell again, but I don't lose its address because it is still in the store address in the store table. So all three operations, insertion, deletion, and updation, there is no ambiguity at all. Information is only appearing at one place, is only updated at one place, is only deleted from one place. So where lies the problem? Nowhere. Right? So yes, I had two tables. I've gone from two tables to three tables, but again, the issue is that we didn't start right. Right? So I'm showing you how it is tedious if you don't start right. So that's why the first thing that is done when you build databases and tables is you think. So those guys are database designers. The designers sit down to think. Usually designers and programmers are the same group, but designers are people who are responsible to think what should be the design of my tables, so that in the long run, we don't have to keep doing all this nonsense. You will have to alter your tables. You will have to create new tables. You will have to move information from one table to another. You will have to do all this. You just can't say, oh, let's drop everything and then recreate everything. That's not how the world works. You know that, right? So if you didn't start right, you will have problems. Now let's run this. And I think we did. I'm not so sure. Let's run it. I have a syntax error. Already exists. TBL toys already exists. Where? Create table TBL toys. Did I forget to drop it? No? Why does it say it already exists? Is it coming from somewhere else? Can I clear it? It says already exists. Let's try it. Describe. Oh, here it is. No? No, it's fine. Let's see. Error dropping. Oh God, the dropping problem is very difficult for me. It's not again you. I don't know why it creates problems. What should I call it? DB2NF. Oh God, I can't think of a good name now. I'll just change the toys to toy, okay? There. I definitely need a computer change. It's 3 years old. It's misbehaving now. Many sectors are bad. Okay, there, it runs. Its hard disk seems to be misbehaving a lot. I haven't even defragmented it actually for a long time since I've been teaching for a year. You should always clean up your hard disk and take care of defragmentation. You know what defragmentation is? When you delete files from different parts of your laptop or your own disk, what happens is empty spaces are in different clause. And if you want to kind of put them together back again, you use a utility and then it will put it back. Right? That's one thing. Two, when sometimes sectors go bad. When sectors go bad, you are not able to save anything on it, but you're also not able to delete anything from those sectors. So things go old, they die, right? And it's just machinery if you kind of think about it. But this defragmentation, of course, you should take care of. So if you keep deleting and that blocks of deleted stuff, empty spaces are all over, if you want to kind of put them together again, I think there is a utility in Windows called defragmentation or something. Look it up and then do it. But my problem is coming from bad sectors for sure. I can delete something. That means those sectors have gone bad. Okay. Okay. So that's second normal form. Understood? Let's look at the last one. I couldn't make up an example about toys in the third normal form. So what I did in the third normal form is I took a completely new example. Believe it or not, this is an example I also did as a student. Okay. So this last script has tables that all tables are in the first and the second normal form, but they are not in the third normal form. Okay. So I've created a DB called books, not third normal form. Again, if it will create a problem, I'll do a T, I'll remove the T and do it and then do it. But let's look at it now. Look at the table. I have only one table, so don't worry about it, not much to do. But look at the table. The table is about books. Every book has an author. Every book has an title. Every book is published by somebody, so there is a publisher ID, okay? And there is a publisher city. And the publisher city, again, is not dependent upon the primary key at all. The primary key of this table, author, comma, title. Again, third normal form, your keys will be, no, not necessarily composite. No, it could be singular also. But the definition is different. Now, look at what should be the key of this field. Let's first decide that. Will author alone do? No, because author can write many books. Will a title alone do? No, because books on Java could be, though people choose not to call it the same, but a book may be named the same. Intro to Java, so can't use it. But the combination of author and title will always be unique. An author writes a Java book, you will call it Java 1, and writes another book, either will call it Java 2 or will say something like something. He won't call it Java 1 again. So that combination is unique. A particular publisher is going to publish it. The same book, same author, only one publisher publishes. So publisher ID is completely dependent upon that combination. But look at publisher city. That's like an address. The city is saying where the publisher is. It has nothing to do with the primary key at all. So now, when is a table said to be in the third normal form? A table is said to be in the third normal form if it is already in the second normal form. That means automatically also in the first. And every non-key field means that does not take part in the primary key, is non-transitively or directly dependent upon the primary key. There is no transitive relation. Here the transitive relation is city is dependent upon ID and ID is dependent upon the primary key. This is called indirect. This is called transitive relation. And therefore I use the word non-transitively or directly dependent upon the primary key. So definitely publisher city is not dependent on the primary key. Actually, it is not dependent. It's only dependent on the PB ID and the pub ID is further dependent upon the primary key. So what will you do? You'll again have to break up the tables. Think about it. What should go where? Two tables for sure. Publisher ID and publisher city go into one table. And what goes into the second table? Author title and publisher ID go into the second table. I hope you know that only one publisher can publish a book written by an author. No two publishers cannot publish the same book, right? So publisher ID is dependent upon the primary key, the composite primary key, and the publisher city is only dependent upon the publisher ID. So what will I do? So here are some examples that I took. I kind of put some book names into it, but again, you see, there is no relationship between the city of the publisher and the book author title. There is no relationship. So we will have to break it up. So let's run this to see that it is running correctly, so that before I put it, I take care of it. See, yeah, the no is causing a problem. So definitely, after this semester ends, I'm just waiting for the semester to end. And again, if you can think of something else which is not good, we can change it. Author is a varchar, title is a varchar, publisher ID could be unsigned. Let's at least improve this one because this is a table that is not related to anything yet. And the publisher city is varchar 2025 is fine. So I just made the publisher ID as unsigned. You can go smaller than int also. Even a small int will do. But God knows how many publishers there are in this world. But even a small int will do. Okay. So now let's run this once again. I've just changed the name of my database. I'm good now. Now, keep in mind we changed the publisher ID to unsigned. How will I convert it into a third normal form? So to convert it into a third normal form, definitely the not has to be removed. Who knows, even the book may have to be removed. It's really acting very weird. I have no clue. I just want to finish off and then see that I don't have these problems in my exam when I mark it, and then I'm good to change it. Okay, I changed it to unsigned. So here is my table publisher, in which I'm only putting the publisher ID and the publisher city, right? And my second table, which is very similar to your first table, is this one. All it has is author, title, and publisher ID. Again, make it unsigned here, please, because we made that change. And say not null. And create a foreign key constant, which says from where is it picking up its value. And the primary key is author and title. Put values into it. You don't have to put the publisher city at all. And again, look at why it is good. I want to add a new publisher. I just have to add this information here. I want to change the city of a publisher for whatever reason their address has changed. I only do it at one place. So information about publishers can be added even though they're not publishing a particular book. Right? And deleting, same thing. Updating, same thing. I want to delete. I've gone out of business. I don't want to do the publishing business anymore. I delete myself from the publisher, but I also have to delete that record from the, no, that book was already published and finished. So again, you have to take care that the problems arise in these operations. You update, delete, or insert. These three operations have to be taken care of. No duplication of data, of course, you have to keep in mind, because duplication of data will always create problems in updation and deletion. There will be, right? So if these three operations, inserting records, updating records, and deleting records, is not causing any issues, that means your design is good. And therefore, these rules have been made for you. If you follow these rules, you create a table in the first normal form, or in the second, or in the third, and there are more. There is a fourth normal form, there is a fifth normal form, and at the top there is BCNF, Boyce Codd normal form, which I don't even remember, but that's at the top. If you follow these design principles when you create tables or when you create a database and you design your tables, in the long run, you will never, not, I should never say never, you will have less chances of making changes to your table structure. And that is the most important. You think of it. Don't think of tables that I use in class which have 10 records or 20 records. We are talking about databases which have trillions of records. You can't drop databases and recreate them. You can't say, oh, this table is not available for the next 2 hours. Notice how often does your Blackboard go out of operation? Maybe once in a semester. And that too, they try to do it during late hours. Right? Because all this, you can't just close something and say, oh, the world will come to a close. Though Blackboard is not our world, but still, if I have to mark something or I have to be careful, then I say, okay, I should be okay. I'm okay. I always check what date or time they are giving so that it's not, of course, they never do it on a weekday. And they do take care. You can't imagine, oh, banks will say, oh, our ATM machines are not working. They can't do that. Oh, we are doing something, we are doing a backup, we can't do that. It cannot happen. Banks, therefore, keep their data at more than one places. The BMO in Barry's, duplicate data in Toronto or Markham branch. That's what they told us. Because if one goes down, there is an option. You can say, what if the second also goes down? Then there is no, then you have 3. What if the third also goes down? But at least you always duplicate data so that you have a backup. And you should always also back up your laptops, which I don't do. I always think I should, and I never do it. I only do it at the end of the semester. But I usually do it once a year. But some people, like people who work in the networking, because they're so good with all this, all their machines are being backed up constantly every day. I mean, in their home computers, all their home computers just are backed up to an extra storage every day. And that's something that should be done. Anyway, okay, so coming back to this, what have I done? I've created two tables, one with only the publisher ID and the publisher city, and second with the title, with the author, and with the publisher ID. And again, if you need who's this to, that's not a big deal. Who's to, you can always find it who is to from here. Right? So if I wanted, and let's run it once just to see that it is running. I haven't made any syntax errors. Oh, I have. Don't tell me no, something was, no. Oh God. Something already exists. Table books already exists. Table books already exists. I've already said drop it. Create the table. Table DBL3NF already exists. Okay. So I'm going to change the name of my database. That's the only thing I can think of. The easiest thing to do. Okay, all works fine now. Now that you know your joins, I didn't do it in second because I thought I was short on time. I'm still short on time, but I can do it. Now tell me, if I wanted to find out who is the publisher of the first book, whatever it is, author is John Derry, Easy Being Green. I pick up it from here, the two from here. I go to the other table, pick up the name of the publisher or whoever, the city of the publisher from the other table and get it. So let's try today. Let's try to show all books published in. So do a question. Display. All books published. You can do anything. You can say published by one, for example. And that one is New York. Okay. So even two is New York, but all books published by pub ID 1. Right? That's all I can say. Display all books published, display not all books, display the city of all books published by publisher ID 1. So you want to display the city of all books and their names also if you want. Display the city and book information. What is the book information? The book information with the author name and whatever title of all books publisher by publisher ID 1. Okay, do it. What will you do? You want to select city for sure, but we also want to select the book information. So we'll go title and author also. Okay, author. The book information is author, title, and we want to show the city. What was it called? Pub ID, pub city. It was called pub city, guys, not city. Okay, so here, from which two tables? Definitely we have two tables. One is called table books and one is called table publisher. Book or books? Books, I think. There, right? What is your joining condition? Where the publisher ID of this one, table books. Take this Control C. And what was the field called? Pub ID. Why don't I use my inner joins? Then I don't have to do all this. Is equal to the publisher's pub ID. Hopefully it's also called publisher ID there. Pub ID here and pub ID here. There it is. And the city was called. There it is. You have your information. So whoever, and this guy was, I don't know how many books, 2 books. And Timmy Help and Timmy is the 2 books. And the city is New York for your information. Oh my God, how come I have something is wrong? Something is wrong. What's wrong? Oh, match of 1? No, what is wrong? In condition, they should be equal, right? So what is wrong in the condition? The condition is right. One of here should match with one of there, and one of here should match with one of there. Okay, what is this called here? It is called publish PUBID. And there it is also. What is wrong? How come we have wrong answers as if the joining condition is not present? Okay, let's see. Author, title, pub ID, constraint pub ID picks up its value from pub ID. Okay. Pub ID 1235. Pub ID is an unsigned primary key. Here pub ID should be an unsigned int. What is wrong, guys? Author, title, pub city from the two tables such that the pub ID here. Oh, we were only looking for publisher by and. Oops, I've missed my and. And PBID is 1. Forgot that. So if you're joining it, join 2 with 2's, 3 3's. Who's pub ID? Published published H is missing. And this information is in the table books. Of course, the answer was right, but our solution was wrong. Right? I forgot that I'm only interested in people in publisher ID 1. I didn't add that condition. I added my joining condition, but I didn't add my condition that I wanted to check. So now only 2 results because there are only 2 PBID ones. There it is. 2 rows written. Makes sense. Right? So it's not that, oh, if I don't, what will I do? How will I get my results? Of course, you will have to write joins and subqueries. That's what you will have to do. So if I wanted to say, oh, give me all those books that are published in New York, I'll have to find out the, so let's do another one. It's not a big deal. You just have to know how to do them now, right? All books published in New York. So the first thing I have to do is I have to find out which publisher ID is in New York. You can use it using the subquery, right? So let's do it using subquery because you've done that too. So let's say select the pub ID. Oops. Let's select the pub ID from the table publisher. Come on. Where pub city, you can say is equal to New York just because we know, or if it was a like, we would have gone with like. Okay, so here is the city with publisher city New York. Let's double check just for the heck of it. Pub ID, pub city, pub ID and pub city. And was it called New York? I am almost positive it was called New York with a blank. Yep. Okay, so there it is. Now, I'm interested in all those titles or maybe authors or all those titles, all books you can say, or all titles and books, all book information. So now select the author and select the title. Again, it doesn't matter. The sequence doesn't matter. So the title and author from which table? From the table books. Shh, guys, I can hear you. Whoever is talking. Where the pub ID is in this set. There you are. All books published in New York will come up. Right? So you can always find a solution. You've done it. You've done your joins and subqueries now. You don't have to worry about it. So a table will never be the solution. It will always be more than one tables. Now let's run it. So there were 1 and 2, 2 ones and 2, 3. I should have 3 answers. There were 2 from the publisher 1 and there was 1 from 2 and 2 was also in New York. Done, job done. Right? So these are the 3 first normal forms, normal form 1, 2 and 3, but definitely there is 4 and 5 and BCNF. In your course, it's only till 3. I'm not sure what happens in the advanced course, but I was not able to kind of do them. I thought I would while I was teaching, but at least this has given you some idea of how a table is not and then how you break it up also. And I'm glad I did it in the last week because now you also know your joins and subqueries and we were able to use them to show you the answers. So I think I'll always keep my normalization to last week. It was usually it's chapter number 7 or something. It's done in between, which is not a good, that time I can show you these joins and subqueries, right? So I'll take all of these files and then again put it on Blackboard. The only thing that I missed is I didn't do a join or a subquery in the normal form in this toys, just because I thought I would run out of time, which I have, but I will put one if I want to. Okay, you can always show an answer by joins and subqueries. So I'll just put this back for now, and if I make a change, I'll again put it back. So I'll remove this normalization. So we did make changes. There were some syntax errors to start with, and then I made changes because of my database problem space. And I'm going to put this back on for you under, it was under weekly learning. Or maybe I'll just put it here. I'll add it to your week 13. So summer 2018 normalization.sub. So there, it's under week 13, okay? I'll replace the one on weekly learning because the other section will do it tomorrow. Okay, guys, thank you for your patience. I've taken care of everything that needed to be done in this course. I haven't left out anything. So hopefully whatever you've learned in this course will come handy as you move on to do your second course. And you've learned something out of the course, hoping that it was beneficial, because that's the whole motive of it. I'll see you next week with your final exam. Please concentrate on joins and subqueries, advanced select statements. Okay? And you can use whatever like you did in midterm. I'll kind of make the same kind of format.